now we're going to take what we learned about quadratic functions, quadratic formulas, and we're going to apply them to real world situations. Yeah, so this is basically what we're going to do. We're going to take practical situations that can be modeled using this function, this equation, and we're going to answer some questions about them. So let's look at this. The area of a rectangular garden of length x meters is given by, so basically there's a garden here that looks something like this. Actually, I didn't draw that very well. It'll look something like this, and there'll be, so this will be 6 meters, and then this will be x, x, x. I haven't drawn that well, but it'll look something like that. It'll be a rectangular garden with a square in the middle, and the garden is like here. And we're going to figure out the area of the garden using this quadratic formula. Okay, so again, they've given us a table of values to use in the question, so we're just going to go ahead and fill it in. When x equals 0, the area is 0. If you put 1 in there and 1 in there, 6 minus 1 is 5. And so on, we just keep putting it into our calculator, getting the answer. And then let's plot it. So we go through 0, 0, and then it was 1, 5, and then it was 2, 8, 3, 9, and back down the other side. Let's join it up. It's a good idea to put these arrows when you're drawing quadratic functions and exponential functions as well. I should have mentioned this back then, because these equations continue for any value of x. Okay, we've only calculated these 7 values, but really we can put any x in here. We can keep going as long as we want in either direction. So we put these little arrows on the heads of our graph to indicate that we know that the function extends in both directions infinitely. Alright, so let's answer part B. Use the graph to estimate the area of the garden when the length of the garden is 4.5 meters. So what we're going to do is we're going to look at 4.5 meters here, go all the way up till we hit the blue line, and then go across and see exactly where we are. So we're in between 6.5 and 7. Let's say we're at about 6.6 meters. Sorry, 6.7. Let's go 6.7. Now, the next one, part C. What is the maximum area of the garden? That is the point that's at the top of the curve. I didn't draw my line in a very good spot, but you can see here that it's when the area is 9 meters squared. We're never going to have any area that is bigger than this. And what is the length of the garden that we need to get this maximum area? We can answer this question 2 ways. We can look here. When the maximum area of 9 is achieved, we have a length of 3. Or we can also get it from our graph. When we hit that point 9 there, we're at x equals 3. Yeah, there you go. That's a typical question that you'll be asked here, and you just have a couple to practice now. So yeah, get started. Let me know if you need help. Thanks, guys.